Hi everyone, welcome to episode 8 of my dev diary for Project Husky. This sprint I decided to do something a bit different and run video capture whenever I was doing development rather than trying to create clips to fit the script afterwards. It means there's more footage to go through in the editing stage, but hopefully I'll have more coverage of the actual work I did. I didn't achieve as much as I was expecting this sprint, as I had to reacquaint myself with the 3D modelling tool Blender. I haven't needed to use it for several years, so I was pretty rusty to start with. I also ended up having trouble with the orientation of models in Unity not behaving themselves, and I frequently hit gimbal lock due to ignorance on my behalf, which I'll cover shortly in this video. So, moving on. This sprint I improved on the eye control system I built last time. To start with, I decided to replace the temporary models I'd created with primitives in Unity with proper meshes created in Blender. Once I'd created the eye model, I imported them into Unity and hooked them up to my eye control script from last sprint. At this point I realized that the script was actually full of bugs that were only obvious once I started using a proper mesh. One thing I didn't realize at the time is that Unity's transforms deal with the local coordinate system by default. So if you want to move an object by 1 unit in the positive x direction, but the object has been scaled by a factor of a half, it will move by half a unit, not 1. I fixed the issue by sizing the objects correctly in Blender and removing all scaling and rotation in Unity. Liberated from the effects of the scaling factor, the movement constraints on the eye were suddenly too big, so I spent some time fixing that up. I also realized that due to eliminating a rotation transform, the eye control was translating the pupil in the wrong plane. In the end I had to almost completely rewrite the eye scripts from last week, but I'm much happier with the result. During the week previous I also realized there was an optimization I could make to the oval equation that I used to constrain the pupil position. This greatly simplified the calculation. The other major thing I did this sprint was to add the ability for objects to be picked up and dropped. I had a few false starts as I wasn't happy with my initial approach, but ended up with a design where objects that can be picked up have a carryable component, and entities that can pick up carryables have a carrier component. This defines a few properties, such as the position and orientation of the object relative to the carrier when it is being carried, as well as a reference to the object itself. During the development of this feature I ran afoul of the same transform issues I had when I was creating the eyes. For testing I created a basic cylinder primitive in Unity, and ended up stretching and rotating it just like I did with the eyes I had so much trouble with earlier. I eventually realized that the thing that keeps messing me up is the fact that when you create a cylinder in Unity, it is oriented such that the circle part is facing upwards, which is fine for 3D, but my game is based in Unity's 2D mode, so the entire thing needs to be rotated 90 degrees, which messed up the entire notion of the object's local orientation, and led to a gimbal lock, which basically means I couldn't actually rotate the object in the axis I needed it to move, as the first rotation had completely redefined the axes. I ended up creating a simple hunting spear model in Blender, orienting it correctly and importing it without applying any transforms, and it worked properly. The major learning I took out of this sprint is that Unity's transform system doesn't work how I expected, and the default Unity primitives are great for prototyping, but once you start needing to do anything more complex, it's better to create a properly sized and oriented mesh through a 3D modeler such as Blender. Another fun discovery I made was that the coordinate systems for Unity and Blender don't match up. Unity's up axis is the Y coordinate, while Blender's is the Z coordinate. I think one's left-handed and the other right as well. At this point I threw my hands in the air and just gave up. That's it for this fortnight. In the next sprint I'll be redesigning the player controller to be less coupled with the input system, and start work on the story manager, which will manage the story? See you next time.